Good morning students, welcome to the CS department again. As we all know, we were dealing with the third chapter, that is data representation, correct? We all went through the number systems, different types of number systems. In that, decimal, binary, octal, hexadecimal, we have seen the basics of all the number systems. But now we were trying to convert a number in one number system to another number system. Okay, what we have already learned in the previous video, we have learned the conversion from binary to decimal and decimal to binary, that we have already learned. Okay, so now let us go to the next number system, that is decimal to octal. Okay, decimal to octal. Now you please remember, I am giving you one formula that you have to apply everywhere for any conversion. Okay, you have already studied this in binary. What is that? If there is a decimal number given, okay, if there is a decimal number given and you want to convert it to any other number system, okay, so decimal converting to another number system can be what? Can be binary or hexadecimal or octal. Okay, what is the formula or what is the process? The process of converting a decimal number to any other number system, the process is factorization. Okay, factorization. You know what is factorization? In binary, what we did? Factorization means we all went on dividing the number by 2 and we noted down the reminders and finally we combined all the reminders, correct? So decimal to any other number system, if you want to do, you have to do the factorization. For example, decimal to octal I am doing. Okay, decimal to octal, what are the steps? Divide the given number by 8, the factorization method it is. Divide the given number by 8, any number is given, divide it by 8. Note down the reminders on the right side. Okay, we always have done this when we were doing the conversion for binary. Okay, repeat the step until you can't divide it further. Collect the reminders from bottom to up, isn't it, to get the final required result. Okay, so when a decimal number is given, if you want to convert it to any other number system, you should always do this method, that is factorization. Understanding? Now if any other number system is given, okay, say binary or hexadecimal or octal, any other number system is given and you are asked to convert it to decimal, then what to do? Okay, there is another number system 1101, a binary number is given. I want to convert it into decimal. How did I do? In the last video, you remember, you took W, B, V, weights, bits, values. Bits you wrote separately, you wrote the weights and then the values you added, isn't it? So which method has to be followed? W, B, V. Okay, so please make a note of this. It is an important a formula type that you have to remember. Okay, if a decimal number is given, if you want to convert it to any other number system, then you have to go for which method? You have to go for factorization. If any other number system is given, okay, and you want to convert it to decimal, then WBV method has to be used. Okay, so shall we see now which is the conversion needed? Decimal to octal, decimal to any other number system, that is factorization. So factorization steps are given here, you already know this. In binary we divide it by 2. In octal what is the subscript needed? 8, isn't it? So divide the given number by 8 and repeat the same procedure. Okay, shall we solve some examples now? Fine. So what are we doing now? We have got a decimal number, we want to convert it to octal. Okay, so factorization method we have to follow. Fine. So give me a number. Take any number of your choice, your date of birth or your year of birth, anything you take, and you have to convert it to what? Octal. Okay, so can we take a number, say 512. This is a number 512. This is what? a decimal number. Okay, I want to convert it into what? Octal. Correct? I want to convert it into octal. So what I have to do? Take 512. Okay, divide it by what? 8. Correct? Divide the number by 8. Fine. When you divide this by 8, try to divide. Try to see what remainder you get. 8 6 are 48. 3 is the remaining. Then 32. That is 8 4 are 32. Any remainder is there? No. So 0 is the remainder. Am I right? Is that calculation correct? 512 divided by 8. 8 6 are 48. 3 is remaining 32. So 8 4 are 32. 0 is the remainder. So remainder I am writing here and the quotient I am writing here. Is that fine? Okay, you have understood this. Then again repeat the step. That means 64 by 8. 8 8s are 64. So 8 8s are 64. Again the remainder is 0. Then again divide by 8. 8 1s are 8. Then again the remainder is 0. Correct? Can you divide it further? Repeat step 1 and 2 until you can't divide further. Okay. Can you divide it further? No. So you have to stop here. Then collect the remainders from down to up. How did you collect the remainders in binary? This is the way, isn't it? So this is the way. Collect 1 0 0 0 1 0 0 0. So what happens to be 512 in your decimal number system happens to be 1000 in the octal number system. Are you clear with this? Can we try one more example? Okay, take which is the year going on, 2020, your favorite year, because you are sitting at home enjoying the things, isn't it? So 2020 is a decimal number. I want to convert it into octal. Shall we take that? Fine. 2020, go on dividing by 8. 8 2s are 16. 4 is remaining. Then it is 42. Right? It is 42. So 8 5s are 40. Okay. 40 means again 20 is remaining. So 8 2s are 16. Correct? Again 4 is remaining. You can divide it, right? 220 divided by 8 you do. You get 252 as the quotient. Last 4 remainder you get. Okay. So again go on dividing. 252 divided by 8. 8 8 3s are 24. 12. 8 1s are 8. 4 is remaining. Am I right? Fine. Then 8 8 3s are 24. Correct? 8 3s are 24. 24 means how much is remaining? 7 is remaining. Okay. Can you divide it further? Not possible. So collect the remainders from bottom to up. 3 7 4 4. So the 2020, what happens to be in decimal, is in octal actually 3 7 4 4. This is the answer. Did you all understand this concept? How to convert the decimal number to octal? Go on dividing by 8. Understanding? Then note down the reminders. Do it until you can't divide further. Lastly, collect all the reminders. Simple. Okay. As you did for the binary, the same procedure you are applying. So this method is called as factorization method. Are you fine with it? Okay. So pause the video and try. I am giving the assignments now. Try them. Okay. Then we will go further. Take the assignments. What all? See, all of you try your year of birth. Okay. All of you. If it is 2002 or 2003, whatever is there, try it and try to find the octal equivalent of your date of birth or year of birth. Okay. And some more examples. 6539. Okay. This is a decimal number given. You have to convert it into octal. Okay. And some more, any number, 16,535. Okay. This is a decimal number given. Convert it into octal. Okay. So these two examples you have to try and send me the assignment. Okay. Shall I go to the next Fine. Now, you already know how to do it when an integer number is given. But when a point is given, what to do? When a point is given, what we have to do? That we have to see here. For decimal part, or you say for fractional part. For fractional part. Okay. You already know how did we do this for binary. What did we do? If point was given, we would go on multiplying it by 2. I am not writing the steps again. I hope you have written the steps for binary. The same steps you use here also. The only changes when we were doing for binary, 2 was the base. Here 8 is the base. That is the difference. Only that much. Okay. For example, say a number 100 point, okay, 100 is the number that you have to first convert to octal. By what method? By factorization method. 100.3125 is given in decimal. This I have to convert it into octal. Okay, this is the problem given. 100 you can do. How to do that? Yes, 8 ones are 8, 2 is remaining, 8 twos are 16, 4 remains. Am I right? Okay. Then 8 ones are 8. Again 4 remains. Can you divide further? No. So this is the answer. 144. Okay. So 100 can be written as 144 in octal. But what about this 0.3125? That I have to concentrate now. This you already know. 0.3125 has to be converted to octal. What are the steps? First, multiply this number by 8. Multiply the number by 8. And what are the two things you get? Carry and product. Isn't it? You get carry and product. Okay. Shall we do that? 0.3125 into 8. So 8 5s are 40. Am I right? Then 8 2s are 16. 16 plus 4, 20. Correct? Then 8 1s are 8, 10. 8 3s are 24, 25. And what remains? 2. So 2.5000. That is nothing but 2.5. That means 0.5 is the product you got. 2 is the carry part you got. You already know this in binary. So I am going a bit faster here. Okay. So what is the carry part I got? I got 2. Correct. And product part I got 0.5. Let me reverse it so that you will understand it easier. Product and carry. 0.5 in product and 2 in carry. Fine. Then what? Then consider the carry part, product part, and multiply it by 8. Isn't it? This is how we did. Only product part we would consider and again multiply it by 8 until we can't multiply further. Okay. So 0.5 into 8. What is the answer? 0.5 into 8 answer is, shall we do? You have to say it without calculating also. You have to be fast in maths. Okay. 8 5s are 40. 4.0. 4.0 means product part is 0. The carry part is 4. Am I right? Correct? And how did we collect the carry part? Downwards. Okay. Reverse of this we used. Isn't it? In factorization, we did like this. From bottom to up, we used to collect. But in fractional part, only when the point is involved, we collect it from top to bottom. So 24. And hence 144 and 0.24. That you have to combine. So 100.3125 can be written in octal as 144.24. Am I right? 144.24. Okay. This is the way to deal with the fractional part. I hope you all have understood. Is it? Can we take some assignments here? I hope you have written this. Okay, pause the video in between and you note them down and again go for the assignments. Okay. So assignments. Okay, a number is given, say 312. Okay, 312.625. Okay, that you have to convert. See, if you are getting many steps here, okay, please note it down. If you are getting many steps, see here in 2 steps I finished. Okay, if you are getting some 6 to 7 steps, what to do? Stop it at 4th step. Please remember, stop it at 4th step. Okay, till 4 digits, whatever decimal part you get, that is enough for the exam. Fine. Okay, so this is the decimal number given. I want the octal equivalent of that. Then another example, 619. Okay, 619.3 anything 0.125. Okay, 0.125. This is also a decimal number. You have to convert it into octal. Okay, so this is done for decimal to octal. Has everyone understood this? Okay, students, now the reverse process of what we have learnt just now. We learnt decimal to octal, okay, by factorization method. Now let us go to octal to decimal. From any other method, if you want to come to the decimal, please see the formula I told. You need to follow WBV method, weights, bits and values. Is it right? So what are the steps for this WBV method? You already have done this in binary. It's just a repetition. Write the bits separately. Write the corresponding weightages. That means positions with respect to powers of 8. Why 8? I am going for octal number. Correct? Then multiply the weights and bits and record the values. Okay, and write all the values, then add them. Okay, this is the method. So let us take one number and start just the problem. 234.56. Any number. 234.56. This is the octal number. I want to convert it into decimal. Now please remember, when it is octal number, the digits have to be less than 7. Only from 0 to 7 you have to take. Okay, 8 or 9 should not come in this. Correct? Fine. So weights, bits and values. Am I right? So bits you have to write 234.56. Is this clear? 234.56. Okay, weights have to be the respective powers of 8, isn't it? So just let me write 8 first. Okay, then which is the units place? Just before the point, this is units place. Units place will always have what as the power? 0 as the power. Am I right? 8 raised to 0. Then as you move to the left, the powers have to increase. 8 raised to 1, 8 raised to 2. Correct? And as you move to the right, the powers have to decrease. So 8 raised to minus 1, 8 raised to minus 2. Is this clear? Can we write the values now? We have already written the weights and bits. Correct? So with weights and bits, you have to multiply them both to find the values. Okay? So 8 square, that is 64, into 2, right? It is 128. Correct? Then 8 raised to 1, that is 8, into 3, 8 3s are 24. Am I right? Then 8 raised to 0, that is 1. 1 into 4 is 4. Correct? Now 5 into 8 raised to minus 1. Okay. So this, when it is 8 raised to minus 1, it is nothing but 1 by 8. 5 into 1 by 8. Now what is this 5 into 1 by 8? That means 5 by 8 you have to do. 5 by 8. Okay. Point you take. Then yes. What's the next? 8 6 are 48. Correct? 8 6 are 48, then 2 remains, you take 20, correct, then 8 2s are 16, okay, 4 remains, then 0, 8 5s are 40. So this 5 by 8 will be 0.625. Is that fine? 0.625. Okay. Then what's next? 8 raised to minus 2 into 6. 8 raised to minus 2 into 6 means it will be like 6 into 1 by 8 raised to 2. 8 raised to minus 2 means 1 by 8 raised to 2. Okay. 6 into 1 by 8 raised to 2, which happens to be 6 into 1 by 64. Please use the calculator and do 6 divided by 64. What is the answer that you get? 0.015625. This is the answer you get if you do 6 by 64. Okay. Next, what's the last step? Add all the values. You have got all these values. You have to add them. Okay. 128 plus 24 plus 4 plus 0.625 plus 0.015625. That you have to add. Shall we add it? 124. Okay. Sorry, 128. Then 24. Then 4. Okay. Then 0.625. Am I right? Then 0.015625. Okay. This is the thing. Then say 5, 2, 6, 5, 5, 10, 2 plus 2, 4, 6. 0.640 something. Okay. Take up to 4 steps I have taken. Take up to 4 decimal points. Okay. Here 8 plus 4, 12. 12 plus 4, 16. 2 plus 4, that is 5 and 1. So 156.6406. This is the answer. 156.6406. This is the answer for 234.56 in octal converted to what? Converted to decimal. Okay, this is the meaning. Have you all understood this? Can we take some assignments now? Okay. Given an octal number, that is 439.26. Okay, 439.26. You have to convert it into decimal. Is that possible? Concentrate on the number again. What I have given? 439. This 9, is it an octal number? No, not possible. Only 0 to 7. So this 9 has to be removed. Correct? 9 cannot come. Any other number? 436.26. That is fine. That is an octal number, valid octal number. You have to convert it into decimal. And one more, 7125.5. This is an octal number. You have to convert it into decimal. Okay. Please try this and send the answers. Okay, students. Now, having understood the conversion from decimal to octal and octal to decimal, we come to the next part, that is decimal to hexadecimal, the last number system. Okay. What is the base of hexadecimal? 16 is the base. Correct? How many digits were there? 16 digits were there. Which were the digits? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There was no 10, 11, 12. It was A, B, C, D, E, F. Correct? Hexadecimal number system had 16 digits. 0 to 9. Correct? And A to F. These were the digits, isn't it? Now with these digits, we have to convert the given decimal number to hexadecimal number. The steps are always remain same. Only changes, divide the given number by 16 because the base of hexadecimal is 16. Okay. Then note down the remainder at the right side. Then repeat the steps, first 2 steps until you can't divide it further, and then collect the remainders from down to up to get the required hexadecimal number. Okay. You already have understood this. Can we just try a decimal number and try to convert it into hexadecimal? Okay. Give a number, any decimal number that you have to convert to hexadecimal. Okay. Take 16,512, any number, okay, any number, 16,512. I want to convert this into what? This into decimal. Divide the given number by 16. Okay, now you have to divide these numbers. You have to be perfect in dividing the number. Then only you will understand how to convert the number systems. Okay, 16 ones are 16. Then 5 you can't take. Okay, so 0 you are taking. Then 51. 16 threes are 48. Am I right? 48. What's remaining? After this, what's remaining? 32 is remaining. 48. So 32 is remaining. 16 twos are 32. Then 0 is the remainder. Am I right with this? 16,512, when you divide by 16, you get 1032 as the quotient, 0 is the remainder. You can please divide it and see. Okay. Then again, repeat the step. 16, okay, you are dividing it 1032 by 16. Am I right? 16 5s are 80. 16 6s are 96. 1032 you are dividing by 16. 16 6s are 96. What is remaining? 7 is remaining. 72. 72 means 16 4s are 64. Am I right? 16 4s are 64. So how much remains? 8 is the remainder. Is that right? 8 is the remainder. Then again 16 4s are 64. So anything that remains? Nothing. So 0 is the remainder. Can you divide 4 by 16 again? You can't do. You can't do means just take the reminders from bottom to up to get the required hexadecimal number. So the number will be 16,512, which happens to be the decimal number. The hexadecimal equivalent of this will be 4080. Is that right? 4080. Okay. So this is one method of finding the hexadecimal number. Okay. Can I take another example? Say, okay, let us take a small number and try it out. Okay, there is a number given as, say, 619. Okay, 619. 619 I want to convert to hexadecimal. Fine. So I have to divide it by 16. Then 16 4s are 64. That I can't take. So 16 3s are 48. Is it right? 16 3s are 48. 13 is remaining. Then 139. 139. Yes, what to do now? 16 8s are 128. Am I right? 16 8s are 128. Then how much remains? Yes, how much remains? You have already taken 16 3s are 48. Correct? 48, 13 was there, 139 was remaining. In 139, 128 gone. 128 means 11 is remaining. Please correctly do it. Okay. 619 divided by 16. 16 3s are 48. Correct? How much remains? 13 remains. Okay. 139 it is. Then 16 8s are 128. Am I right? 16 8s are 128. So 1, 1, 0. So 11 remains. Correct? 11 is the remainder. But please concentrate here. What do you call this 11 in hexadecimal? That you have to write. Okay. 0 to 9. Then 10 is called as A. 11 is called as B. So this has to be written as B. Okay. Don't write it as 11. It has to be written as B. Okay. Now again continue. 16 2s are 32. So 16 2s 32 means what is the remaining? 6 is remaining. Correct? Then can you divide it further? No, not possible. So collect the reminders. This like this. Correct? So 619 in decimal is written as 26B in hexadecimal. This is the method. Has everyone followed this? What happens to be 619 in decimal is the 26B in hexadecimal. Why this B came? I got the remainder as 11 but in hexadecimal there is this 11 what we get in decimal is called as B, correct? So I write it as B, and with this I can say 26B. Is that fine? Understanding? Okay. So let us take some assignments then. Any number you want to give, you can take any numbers you want. Say 2021. Okay. See here, point also exists, decimal point also exists, that you have to multiply by 16 and get. But normally in our question papers that is not asked, and so I am skipping the part, and you already have known the procedure. Okay, just multiply it by 16 and you know the procedure, so I am skipping it. 2021. Okay, this is a number that you have to convert it into, so this is a decimal number, you have to convert it into hexadecimal. Okay, then another say 55,439. Okay, this is a decimal number and that you want to convert it into hexadecimal. So these two steps, these two assignments, please write it and submit. Is that fine? I hope you are clear with decimal to hexadecimal. Now let us come to the last part of this discussion, that is hexadecimal to decimal. Okay, we have learned decimal to hexadecimal by factorizing. Factorizing means dividing by 16, we have already learnt, just the last method. But now hexadecimal to decimal when we are doing, again another system to decimal uses always WBV, weights bits values method. So the steps remain same. Write the bits separately, write the corresponding weightages of positions with respect to the powers of 16, because it is the hexadecimal number. The base of the hexadecimal number is 16. Okay, multiply the weights and bits and record the values, finally add all the values. Okay, so now this takes the step. Can we have one example for this? Okay, 5AF point D. This is the example, 5AF point D. This is which number? Hexadecimal number. I want to convert it to what? A decimal number. Which is the method I have to use? Weights, bits and values. So say weights, bits, values. Okay. Weights, okay, first write the bits separately. 5AF point D, correct? 5AF point D. Then 16 is the base, correct? 16, okay. Which is the units place? Just before the decimal point. This is the units place. So it will have the power of 0. As you move to the left, 1, 2. As you move to the right, -1. Am I right here? Okay. You have to multiply all this, correct? You have to multiply all this. So 16 square is 256, correct? 256 into 5, you have to calculate. 256 into 5, please calculate and say 1280. Okay, 256 into 5, 1280. Then 16 raised to 1, 16. What is A? A is actually, what is the value of that? 10, correct? So 16 raised to 1 is 16. 16 into 10 you have to do, because it is A. The value of A is 10. So it is 160. 16 tens are 160, correct? Then what is the value of F? F value is 15, correct? F value A, B, C, D, E, F, 10, 11, 12, 13, 14, 15. So F is 15. 16 raised to 0 is 1. 1 into 15 is 15, correct? 15. Then 16 raised to -1 into D. What is D? The value of D is 13, correct? 13. So 13 into 1 by 16 you have to do. 16 raised to -1 means 1 by 16 into D. D means 13. So 13 by 16 if you do, it is 0.8125. Okay, please calculate and write the results. Okay, 0.8125. Finally what? Final, add all the values. So you have to add these all. 1280, 160, 15, 0.8125. When you add, what happens? See, 0.8125 will remain as it is. Then 5, then 8, 6, 14, 14, 1, 15, 2, 1, 3, 4, 1. So, what happens to be 5AF.D in hexadecimal actually is a number in decimal as 1455.8125 in decimal. Okay, 1455, 1455.8125 is the actual decimal number that is equivalent to 5AF.D in hexadecimal. Did you all know? Did you all get that concept? Okay. If you have get that, then please try some assignments. Okay. Let me give some assignments here that will complete the conversion. Okay. So assignments, please take FED. Okay, FED 0.69. This is a hexadecimal number. You have to convert it to decimal. Then again AB6. Okay, any number from 0 to 9 and A to F can be there. AB6 point C. Okay, so this is also a hexadecimal number. You have to convert these two to decimal and send the results. Now this completes the concept of number system conversions. Okay, we already have studied what decimal to other number systems, that is using which method? Factorization method. The other number systems to decimal, that is using WBV method. Okay, these two we have studied. But now, okay, you have taken this, fine. What is left is the inter-system conversions. Means, you know this formula already. Decimal to other number system uses factorization, correct? I hope you are remembering the short forms. Decimal to any other number system uses factorization. Any other number system to decimal, okay, it uses WBV method. These two already we know. Okay, but what about if I want to convert from hexadecimal to octal? That didn't come. Only from decimal or to decimal has come. Inter-number system conversions, hexadecimal to octal, what to do? Or binary to hexadecimal, what to do? That we haven't learnt yet, isn't it? That we haven't learnt yet. How to do this now? How to do this now? Okay, just use a logic, an easy logic. What to do? Okay, hexadecimal to octal they have asked, isn't it? Some steps may be added extra, but you'll get the correct result. How? Hexadecimal to octal, fine. First what I do? Hexadecimal to decimal I do. Okay, then that decimal number to octal I'll take. So if I want to convert hexadecimal to octal, first convert it to decimal. Why? I already know the method. From hexadecimal to decimal, what is the method? WBV. This method I know. When I get the decimal number, now that can be converted to octal using factorization, isn't it? So when you are converting some inter-number systems like hexadecimal to octal, then first convert that number to decimal using WBV method, and then later convert to your required number system using factorization. This is the formula, or this is the procedure. Did you all understand that? If say binary to hexadecimal is asked, binary to hexadecimal, how to do this? First take the binary number, convert it into decimal, binary to decimal using what? WBV, correct? Now when you get the decimal, convert it into hexadecimal using factorization, correct? This step may seem little longer, lengthy, but still you can do it and get the correct result. Okay, so if any number system other than the decimal are asked, first bring them to decimal number and later convert to your required number system. This is the procedure. Can we give some assignments on this? Okay, simple thing. This is asked for 5 marks in every exam paper. It's like feed. Okay, this is a number. Which kind of number is this? Can it be octal? No. Can it be decimal? No. Can it be binary? No. It should be hexadecimal. Okay. So feed, F-E-E-D is a number, is a hexadecimal number. You have to convert it into decimal also, binary also, and octal also. You have to try it at home. Okay. So this number first convert to decimal using WBV, later factorize to binary, and same number, what decimal number you have got, the decimal number factorize to octal. Okay. So this in all the number systems you have to convert and tell. Similarly, there is a number 1011, okay, 0.01. This is a, which number it is? Binary number. Okay. This binary number you convert into decimal first, later to octal, later to hexadecimal. That you have to try. Okay. So if you are done with this, then you are perfect in converting all the number systems internally. Okay. Now actually there are methods to convert this hexadecimal directly to octal or directly to binary without going for decimal also. There are some shortcut methods that we will see when you come to the college in the offline class. Okay. Thank you.